Section 11.1, a molecular comparison of gases, liquids, and solids. Some of the characteristic properties of gases, liquids, and solids are listed in Table 11.1. These properties can be understood in terms of the energy of motion, kinetic energy, of the particles, atoms, molecules, or ion, of each state, compared to the energy of the intermolecular attractions between those particles. As we learned from the kinetic molecular theory of gases in Chapter 10, the average kinetic energy, which is related to the particle's average speed, is proportional to the average temperature. Gases consist of a collection of widely separated particles in constant chaotic motion. The average energy of attractions between the particles is much smaller than their average kinetic energy. The lack of strong attractive forces between particles allows a gas to expand to fill its container. In liquids, the intermolecular attractive forces are stronger than in gases and are strong enough to hold particles close together. Thus, liquids are much denser and far less compressible than gases. Unlike gases, liquids have a definite volume, independent of size and shape of their container. The attractive forces in liquids are not strong enough, however, to keep the particles from moving past one another. Thus, any liquid can be poured, and it assumes the shape of whatever portion of its container it occupies. In solids, the intermolecular attractive forces are strong enough to hold particles in close together and to lock them virtually in place. Solids, like liquids, are not very compressible because the particles have little free space between them. Because the particles in a solid or liquid are fairly close together compared to those of a gas, we often refer to solids and liquids as condensed phases. Often the particles of a solid takes up positions of highly regular three-dimensional pattern. Solids that possess highly ordered three-dimensional structures are said to be crystalline. Because the particles of a solid are not free to undergo long-range movement, solids are rigid. Keep in mind, however, that the units that form a solid, whether ions or molecules, possess thermal energy and vibrate in place. This vibrational motion increases the amplitude as a solid is heated. In fact, the energy may increase to the point that the solid either melts or sublimes. Figure 11.1 compares the three states of matter. The particles that compose the substance can be individual atoms, as in argon, molecules, as in water, or ions, as in salt. The state of a substance depends largely on its balance between the kinetic energies of the particles and the interparticle energies of attraction. The kinetic energies, which depend on temperature, tend to keep the particles apart and moving. The interparticle attraction tend to draw the particles together. Figure 11.1. Molecular level comparison of gases, liquids, and solids. The particles can be atoms, ions, or molecules. The density of particles in the gas is exaggerated compared with most real situations. Gas, total disorder, much empty space, particles have complete freedom of motion, particles far apart. Liquid, disorder, particles of clusters of particles are free to move relative to each other, particles close together. Crystalline solid, ordered arrangement, particles are essentially in fixed position, particles close together. Substances that are gas at room temperatures have weaker interparticle attractions than those that are liquids. Substances that are liquids have weaker interparticle attractions than those that are solids. We can change the substance from one state to another by heating or cooling, which changes the average kinetic energy of the particles. Sodium chloride, for example, which is a solid at room temperature, melts at 801 degrees Celsius and boils at 1413 degrees Celsius under 1 atmosphere of pressure. Dinitrogen oxide, on the other hand, which is a gas at room temperature, liquefies at negative 88.5 degrees Celsius and solidifies at negative 90.8 degrees Celsius under 1 atmosphere of pressure. As the temperature of a gas decreases, the average kinetic energy of its particles decrease, allowing attractions between the particles to first draw the particles close together, forming a liquid, and then virtually locking them in place, forming a solid. Increasing the pressure on a gas forces the molecules closer together, which in turn increases the strength of the intermolecular forces of attraction. Propane is a gas at room temperature and 1 atmosphere of pressure, whereas liquefied propane gas at liquid at room temperature because it's stored under much higher pressure.